Welcome to the introductory lecture for EVT 110, Module 1. This course is all about water and wastewater treatment facilities, and so it's important for us to start our conversations with a short discussion of water and why it's important. We do know that water is a very valuable resource on our planet. Plants and animals need water to survive, but we also see that water plays a role in non-living things in the sense that water is very important for moderation of temperatures on our planet. Water has the capacity to absorb a great deal of heat, and so large bodies of water, which actually take up about 3/4 of our planet, absorb a great deal of heat from the sun and help to maintain temperatures that make it possible for living things to survive on the planet. Now we know water is H2O, and you can see in the diagram to the right water molecules that are drawn a couple of different ways. But essentially what we're looking at here is that we have an oxygen atom which has 2 pairs of electrons and then 2 unpaired electrons that have formed covalent bonds with hydrogen atoms. Now we'll talk in our chapter on chemistry about those types of bonds and why they're important, but for right now it's just important for us to know that water is a combination of oxygen and hydrogen atoms. We know that water is not created, so matter can't be created or destroyed, but what happens with water is that it cycles and gets regenerated in our ecosystems. And we'll talk about what that process looks like a little bit later on. We've seen in our recent discoveries and research about the environment that we actually need to refocus how we think about water. For a long time, we've considered water to be a resource that is unlimited, and we now know that that's not necessarily the case. And so we need to focus on using water in a more responsible and sustainable way. And this really is going to be focused on how can we reuse water? How can we reduce how much water we use? And that's because of the decreasing availability of fresh, clean water that's available for us to use. And so what we're going to see is that the water and wastewater treatment process play a vital role in the relationship between our society and our water resources. And we'll talk about that a little bit in this chapter and then more as we go through the rest of this course. So let's look very quickly at some of the sources of water. Essentially, we find water in 2 places on the earth. We can have surface water, which is going to be found above the earth's surface. And this is where most of our water is, tied up in lakes, rivers, streams, and oceans. And this is essentially the water we can see. But we also have water that's located below the Earth's surface, and this is going to percolate through the Earth beneath the surface, and it forms what we call underground aquifers. And this is really just going to be a layer of rock that contains water within it. And so there are really 2 sources of water there. Primarily what we focus on is surface water, but groundwater does play an important role, and we'll talk about that shortly. Now we said earlier that water is not created, but it's regenerated or recycled. And this occurs through the hydrological cycle, which is more often called the water cycle. And this shows a picture of the water cycle and how this process works. And essentially, we see that water is going to be tied up in these large bodies of water in the oceans, lakes, rivers, and also including the groundwater that we have in the earth. That's where all of our water is collected. But water does not stay there permanently. We see that through the process of evaporation, that liquid water gets turned into a gaseous state, and it becomes a part of the air in the atmosphere. The higher the humidity is, the more water we have floating around in our air. And what we see is that that water that's in the gaseous state is now going to rise with air currents, and eventually it reaches a point in our atmosphere where the temperatures are much cooler, and that promotes a process called condensation, where that gaseous water now returns to the liquid state. And this is again going to occur in the atmosphere and promotes the formation of clouds, and those clouds will collect water until they get to a point where they're so heavy, and now we'll see that that water begins to fall back down to the earth through the process of precipitation. And that precipitation can be rain, snow, sleet, ice, various types of precipitation that will bring that water back to the earth. And at this point, the water will rejoin those original collection points and re-enter that cycle at that point. Now, humans have a capacity to intervene in the water cycle. The activities that we perform on a daily basis tend to disrupt the normal flow of the water cycle. And a lot of these are things that we have done in order to increase our quality of life and convenience to ourselves. And we are now starting to realize that these things have a negative impact on our environment, which is why there is a focus on moving towards sustainability. So we use water in our homes and businesses, and this water is going to get treated as wastewater and then returned to the surface water. But the issue with this is that we see a decrease in water quality as a result of use and then treatment. We see that in many parts of the world, there are non-industrialized regions that just discharge wastewater into their freshwater supplies without treating first. And this tends to pollute those waters significantly, which becomes a big issue if you have downstream towns or villages that are then using that water supply, because they are taking polluted water and using it for their own use. And then we also see that climate change, which again is occurring because of human activities, climate change is having an impact on rainfall and may have an impact on water supplies in the future. So there are a lot of ways that humans tend to intervene in the water cycle. And some of the more specific ways that we do this are listed on this slide. And this is some data that I think from 2005, it says on the slide, that shows how water is used most significantly by human populations. And you can see that 40.9%, so essentially 41% of fresh water that's being used is being used for thermoelectric power generation. We also see that a lot of water is used for irrigation, so around 37%. And then we start looking at public supply, so water that's being distributed directly to your home. And then there are much smaller percentages for some of the other uses of water, domestic, livestock, aquaculture, industrial, and mining uses. Now, this use of water by humans creates what we call an artificial water cycle. So rather than the natural water cycle of water evaporating, condensing, precipitating, and rejoining that normal supply of water, we see that water is cycling through our environments or our ecosystem in a different way, where it's actually cycling through urban areas or industrialized areas and being returned to the water supply. So we start with surface waters being withdrawn and treated, and then those waters can be distributed to homes and businesses. As that water gets used, it's then going to be returned through a wastewater collection process where it gets treated and then discharged back into those surface waters. And the idea here is that when we discharge this water that's been treated, it's no longer considered a pollutant because the contaminants have been removed. However, there are still chemicals there from the treatment of the water. And so the idea is that by returning it to the surface water, we're returning it to a large body of water, which will dilute and naturally purify that wastewater that has been treated. We said that this results in a lower quality water, and so you don't necessarily want to immediately then collect that water to treat and use for distribution. But what we see is that in many cases there are downstream communities that will then pick this water up and go through this cycle again. And so this is how we're seeing water cycle through our societies, essentially, through our water and wastewater treatment process. Now we're going to talk about some of the different aspects of water that end up being important in these processes, and one of these is thermal stratification. So thermal refers to temperature, and stratification essentially means that there are layers. And this is an important aspect of hydrology, or the study of water, that impacts water quality. So we'll look at that in just a second, but essentially what we're looking at here is the layering of water based on temperature. And so you can see that in the summer, the upper layers of water tend to be warmer, and that's because they're in the most direct contact with the sun. So these are going to be the layers of water that are constantly absorbing that heat from the sun. And then the deeper layers of water are going to tend to be cooler, and that makes sense because we see much less contact with heat from the sun. In between those two layers, we get what we call a thermocline, and this is just that layer that exists between the warmer and cooler waters. Now in the winter, we tend to see that the top layers of water are either very, very cold, or in some regions, those top layers actually freeze and turn to ice. And then the layers of water below that tend to be warmer because they're not in direct contact with that ambient cold air that promotes freezing of the water. And so in these cases, we created a stratification or a layering of the water. Now, going into the spring and fall seasons, we see that there are changes in this stratification because those top layers of water are going to approach 4 degrees Celsius. Now, this temperature is very important because 4 degrees Celsius is where water is most dense. And at 4 degrees Celsius, that very, very dense water is now going to sink to the bottom, and that's what we call turnover, because that dense water sinks to the bottom and pushes the less dense water back up towards the top. And so we get the oxygen-rich water from surface layers being pushed down, and the nutrient-rich layers from below being pushed upwards. And this is just showing you how that cycle occurs. So in winter we've got stratification, in spring we see a turnover, and then early summer we start to see that stratification. It becomes much more pronounced by late summer and early fall, and then we have our fall turnover that occurs before we get that winter stratification. Now, the impact that this has on water quality is that in the summer, those top layers of water tend to be very warm, and this warm nutrient-rich water promotes algae growth, and that decreases water quality. So you would not want to draw from that layer of water when you are taking water for distribution. Likewise, very cool, stagnant water tends to have low oxygen content and high carbon dioxide content, and can also contain products of anaerobic conditions. And this is going to be byproducts of organisms performing anaerobic cellular respiration. Those waters are also considered very low quality. They tend to have poor taste. And so we wouldn't want to draw from those waters looking at the winter, those deeper waters either. And so a water treatment operator can monitor the water quality and draw from the most desirable locations, which in the summer would be just below that thermocline we talked about, and in the winter would be the surface layers. Okay, so we talked about groundwater being the water that we find below the surface of the earth. We do see some unique concerns associated with groundwater because it is a unique resource. It is useful to us, and we do see that we have access to groundwater by creating artificial wells or pumps. But the thing about groundwater is that it has to be recharged, meaning that water has to be added back. Generally, this is going to occur through precipitation or connection with some surface water, a lake or a stream, something like that. We can also recharge groundwater supplies artificially through direct injections. But the important point is that it does have to be recharged. We tend to change groundwater flow by pumping it up to the surface for our own use. But this can be dangerous because what ends up happening is that we can permanently lower our what we call water table or groundwater supplies if our withdrawals exceed our recharge for a very long period of time, for sustained periods of time. And one of the things that can end up happening as a result of that lowered table is that saltwater intrusion can occur, where our saltwater sources start backing up into our freshwater source, and we get a mixing or contamination of that freshwater source with those saltwater sources. Okay, so previously when we have looked at water systems, so in years past, most of our focus has been on supply. How do we get water out of these sources and into our homes, essentially? But what we're seeing is that our supplies of clean fresh water are in danger of being depleted for future generations. And so now we have shifted our focus away from supply towards sustainability. And so we're now looking at how do we get new supplies of fresh water, either through reuse or through the process of desalination, or taking salt out of salt water. We're also looking at how to decrease demand for water. So we want to get to the point where we can balance the demand that we have with the supply that's available. Because up to this point, we have been using water as though it's an unlimited resource, and so our demand has been exceeding the supply. And that's definitely a dangerous situation to be in. And then finally, we want to balance our human needs, our society's needs, with our ecosystem's needs, because much of what we do when we make these changes to the water table, when we are overusing our water resources, it's going to affect the ecosystems that also need that water to be healthy and productive. And so what we look at moving forward in this course is, why do we use water and wastewater treatment? And so we'll kind of see those themes of sustainability tied throughout much of what we talk about in this course, but it's important to make sure that we're keeping our water sources clean and safe for consumption and recreational use. And so that's really what the water and wastewater treatment processes come down to, is keeping water clean and safe. And so the Environmental Protection Agency is an agency that enforces standards or rules or laws that are in place to protect the human and humans and the environment. And there are two real big laws related to water. The first is the Clean Water Act, which was designated as the Clean Water Act in 1972. It was in place before that, had a different name, and was kind of amended and it took its more modern form in 1972. But it was designed to reduce pollution in our water supply. So this is a set of regulations and laws relating to what we're actually allowed to add to our water supplies. And then the Safe Drinking Water Act of 1974 was designed to protect our drinking water supply by protecting that source water, but then also by applying regulations to the water and wastewater treatment process, how operators in those processes are trained, and how consumers are educated to clean and safe drinking water. So, as we go through this course, we're going to be looking at these various processes, which requires an understanding of 4 basic sciences. And understand that we are not going to give you full courses in biology, chemistry, hydrology, and hydraulics in this class, but we are going to be looking at some fundamental concepts of each of these areas. And hydrology is a study of the movement, distribution, and quality of water, so it makes sense that that would be a part of the water and wastewater process. Chemistry is a study of the composition, structure, and properties of matter, and so here we'll be looking at how water interacts with other substances. Biology is a study of life in living organisms, and so we'll be looking at some of the things like bacteria that might contaminate water supplies. And then hydraulics is a study of the mechanical properties of solids or fluids, and really here we're going to be looking at the movement of water. So just very quickly to give you an overview of the water treatment process, there are 5 basic steps. We have coagulation and flocculation, which is essentially taking those particles that are present in our water and getting them to kind of join together and coagulate to create larger masses of particles, so that in step 2, sedimentation, those large particles can be pulled out so they become very heavy and sink to the bottom of a body of water. And then through the process of filtration, we run water through filters that will take out smaller particles. And then in disinfection, we're going to treat the water so that we kill any bacteria or pathogens that might be present. And then finally, storage and or distribution is our last step. And so this is water is ready to go and be distributed to homes, and you know, this is where it's ready for you to consume. Okay, so that was the water treatment process, how we get water ready for you to use in your home. But then we also have the wastewater treatment process. And so this is going to be where we take the water that is collected after it has been used and treat it so that we can now rejoin it with the surface waters or discharge it into surface waters. There are 4 basic steps here. Primary treatment is where we're going to use mechanical processes to remove solid organic matter. So here we're going to be looking at pulling out large things, screening, pumping, sedimentation. So these processes are going to be involved in pulling out the big stuff. Secondary treatment is where we're going to use microorganisms. So again, bacteria are very commonly used to remove some of the dissolved organic matter, so stuff we can't really see. And this is going to include an aeration process and also sludge and scum removal. And then in the disinfection stage, we're going to remove that bacteria, so we're going to treat the water to kill any bacteria present. And then tertiary treatment is an optional step, which involves removal of excess nutrients, and this is really more focused on the effect on taste of the water. And this just shows you a diagram of that process, and you can see the various steps. Again, primary involving removal of the large particles, secondary involving removal of the stuff we can't see, sludge, scum, disinfection is here included in secondary treatment, and in some literature it's included as its own step. And then tertiary, again, is your nutrient removal to get your effluent, which would be what you would then discharge into surface waters. Okay, one of the things that is going to be important for anybody who's wishing to pursue a career in water or wastewater treatment is the process for licensing, because it's actually a fairly complicated process. And so in South Carolina, our process is that you go through a series of licenses. The first one is a training permit, which anyone can obtain as a new employee. You have to pay an application fee, and you're distributed a training permit. After 1 year of experience, you can then sit for your level D exam, and if you pass that exam after 1 year of experience, you can then be considered a D level operator. And then we see that it goes up through the levels. So once you have your level D certification and 2 years of experience, now you can move up to the level C certification. And once you have level C and 3 years of experience, now you can move to level B. And once you have level B and 4 years of experience, now you can move to the level A operator status. Okay, so that's really an overview of what you'll find in your textbook. But one of the other things that ends up being very important to water and wastewater treatment is understanding some fundamental math concepts, because there will be times that your job will require that you do certain types of calculations. And so with each of these modules, there are some math concepts that we'll be tying in. And so in this module, we're going to cover some basic things: area, surface area, and volume. So area is really the space taken up by a two-dimensional surface or item. So if you were to look at, the area of your notebook, okay, it's the area in 2 dimensions, the length and the width of that notebook, okay, how much space it takes up in those 2 dimensions. And so for a rectangle, the area is going to be the length of that object times the width. For a triangle, the area is going to be 1/2 of the base times the height, and the base is going to be the longer side of the triangle. And for a circle, the area is going to be pi times the radius squared. Now, pi is a constant that hopefully you're familiar with, that essentially we round to 3.14. So anytime you see pi, you can use that number 3.14 in its place. And I will say that for all of these mathematical concepts, there is a document in D2L that outlines some problems and exactly how you would work those problems to walk you through some of these math concepts. Okay, our second concept that we're looking at is surface area, which is very similar to area, but here we're going to take the sum of the area of all sides of an object. So for example, if you have a cube, you can take the area of one side, the length times the width, but then you can add that to the area of all of the other sides, okay, and that would give you the total surface area of that object. So we're looking at the area that the object takes up in 3 dimensions, but only the outside area. Okay, if we're looking at the space that that object takes up in 3 dimensions, including the inside and the outside, then we're talking about volume, which is on the next slide. Okay, so the surface area is the area of all sides of an object. So for a cylinder, we're going to be looking at the area of the top and the bottom, which are both circles. So we'll be using the area equation for circles. And then we're also going to be looking at the area of the side, which if we were to unroll that cylinder, that area is a rectangle. And so for a cylinder, the surface area is equal to 2 times pi r squared. So that's the area of a circle times 2, plus the circumference of the circle times the height. And the circumference is just going to be that distance around the circle, because that's going to give us the long edge of one of our rectangle sides. And so there is an equation here for how to calculate the circumference. It is pi times the diameter, or pi times 2 times the radius, because the diameter is 2 times the radius. For a cone, the surface area is equal to the area of the circle plus the area of the cone itself, so the outside part, which we call the side or the slant of the cone. And that one's a little bit tricky to figure out because it's a slightly irregular shape. But again, the surface area is equal to pi r squared, which is the area of our circle, plus pi times r times L. And L, again, is the side or slant of the cone, which can be calculated by taking the square root of r squared plus h squared. So the radius squared plus the height of the cone squared. And that's how we'll get L. And that's really just using the Pythagorean theorem in order to calculate that, that side with a right triangle. And then finally, we said that volume is going to be the three-dimensional space an object or substance occupies. So it's that surface plus whatever's on the inside. And we're looking at the total space that it occupies. So for a cube, the volume equals the length times the width times the height of the object. For a prism, a triangular prism, the volume is going to be equal to the area of the triangular base times the height. And so we would need to go back to our equation for the area of a triangle to calculate the volume of a prism. For a cone, we're going to be using the equation pi over 3 times r squared times the height. And then for a sphere, we're going to be using the equation volume equals pi over 6 times the diameter cubed. And remember, the diameter is 2 times the radius. So that is everything for this particular module. I encourage you to go through and look at those math concepts explained in greater detail. And then you do have homework to answer some questions about the things we've talked about and some math problems for you to work out.